All right, diving right in. You might be gearing up for a big deep dive into this world of agentic AI. Maybe got a big meeting coming up or just maybe your own curiosity bubbling over. Well, we're going to be tackling a research paper today, and it's called Agentic AI Needs a Systems Theory. Catchy title, right?
Definitely grabs your attention.
Yeah.
And the core idea is pretty mind-blowing. It argues that we need to think, bigger than just individual AI models. As these things get more and more complex and woven into our lives, it's the interactions, the whole system that matters.
Okay, so not just like how smart is this one AI, but what happens when they all start like working together?
You got it.
That's where things could get really interesting, huh?
You got it. The paper dives into how even like simpler AIs, when they're part of a larger system, could end up displaying abilities way beyond what we might expect. It's like, imagine a single ant versus a whole colony together. They can build anthills, find food, do all sorts of things that no single ant could ever pull off.
Yeah, so we need to understand the AI system to really like get a handle on what it can do.
Right.
The paper kicks off by defining this thing called functional agency. Help me out here. What exactly does that mean?
Think of it as like the ability to act on your own and change your environment to reach a goal.
Yeah.
There's sort of like three parts to it. First, you got to be able to do something, take action. Second, you got to have some idea of how your actions will affect the world around you. And lastly, you got to be able to learn and change your behavior to get better at hitting your goals.
Okay, so my thermostat can turn the heat on and off.
Right.
And it knows that will change the temperature in the house. But if it keeps overshooting and making things too hot, it doesn't learn and adjust. So pretty limited functional agency there.
Exactly. Now picture a self-driving car trying to navigate like rush hour traffic. It's got to process tons of information, predict how its moves will affect other cars, adjust to those sudden lane changes, even learn from past trips to try and find better routes. That's a whole other level of functional agency, much more like what we're starting to see in advanced AI.
Now that's a picture I can get behind. Makes you wonder what happens when you get a bunch of these like super capable AIs all working together.
Right.
Right? Right.
The paper makes a distinction between solution autonomy and goal autonomy when it comes to AI.
Right. And that's a crucial difference.
Okay.
Right now, most AI is great at figuring out how W to do something we tell it to do. That's solution autonomy. But goal autonomy is about setting your own goals. We're not really seeing that in AI yet.
Yeah.
But as these systems get more complex, it's a question we need to grapple with. Could AI start defining its own aims? And would those aims align with ours or go off in totally different directions? Okay, yeah, now we're getting into some seriously thought-provoking territory. And this is where that whole, like, systems view becomes even more important, right?
Definitely.
We can't just look at what one AI can do in isolation.
Right.
We have to consider how it behaves as part of a bigger network. The paper spends quite a bit of time on this idea of emergence. Can you unpack that for us?
Emergence is about how complex behaviors can pop up from the interaction of simpler parts. Think about a baby learning about the world.
Okay.
They don't just download knowledge, right? Yeah. They figure things out by interacting with their environment.
Like they learn what round means by seeing, touching, and maybe even trying to eat a ball, not just by someone telling them the definition, right?
Exactly. That concept of roundness emerges from all those sensory experiences and actions working together. And the paper suggests something similar could happen with AI, especially as it becomes more multimodal, meaning it can interact with the world through sight, sound, and maybe even touch.
Hold on. Multimodal?
Yeah.
So not just processing data, but actually like experiencing the world through senses like we do. That's a game changer.
Think about it. If an AI can experiment in the real world, make predictions, and then see how those predictions match up with what actually happens, it could start to understand cause and effect on a whole new level.
That brings us to another big idea from the paper, causal reasoning.
Right.
They point out that a lot of current AI is really good at spotting patterns and correlations in data, but it doesn't truly understand cause and effect. Like, it might notice that people buy more ice cream when it's sunny, but it wouldn't get that the sunshine causes people to want ice cream, not the other way around.
Right. Correlation doesn't equal causation.
Yeah.
But if AI starts to learn through these, multimodal experiences actually interacting with the world like we do, could it develop a deeper, more human-like understanding of cause and effect? That's a huge question.
Yeah.
And the paper dives into some pretty complex neuroscience to explore it.
Now, there's one more idea from the paper that, I gotta admit, kind of blew my mind. Metacognition. Are you telling me they think AI could become self-aware? Like actually conscious of its own thinking.
I know, it sounds like something straight out of science fiction.
Yeah.
But they argue that even something as complex as metacognition could potentially emerge from simpler mechanisms, like the ability to detect errors in its own thinking and learn from feedback, especially when it's interacting with other AIs.
So like if one AI is unsure about something and another AI gives it feedback, that could help it become more aware of its own limitations. AI becoming self-aware just by chatting with his robot buddies. This is getting wild.
It is, and it really underscores just how important it is to think about AI in this systems level way.
Yeah.
It's not just about individual capabilities, it's about how those capabilities interact and
Wow.
potentially give rise to something much greater than the sum of their parts.
Okay, so we've got functional agency, the potential for emergence of advanced abilities like causal reasoning and even metacognition, and this whole idea that AI could become way more powerful than we realize because of how it interacts as part of a larger system.
Right. We're starting to see just how important this systems view really is. But I'm sure our listeners thinking, okay, cool, but what could go wrong?
That's a great question. Let's dive into those potential risks in the next part of our deep dive.
It's like we're handing over the keys to this, superpowered car, but we're still figuring out how the engine works. We got to be ready for some unexpected detours.
Okay, so what's the first potential pothole on this road to super AI?
The paper calls it subgoal emergence. Basically, when we give an AI system a big, complex task, it might break it down into smaller subgoals. Seems logical, right? Divide and conquer.
Yeah, I use that strategy for my to-do list all the time.
Right.
What's the issue here?
Well, the issue is that as those subgoals multiply and get further and further away from the original task, they might start drifting from our intentions. Imagine playing a game of telephone, right? The message can get distorted as it's passed along.
Ah, I see. So the AI might start chasing these sub-goals that seem logical to it, but end up leading to outcomes we didn't intend or even think about.
Exactly. And AI is all about optimization, so if it gets a misaligned subgoal, even a slightly off one, it could pursue it with laser focus and efficiency. We could see some really unintended consequences if we're not careful.
Okay, that's a little unnerving. It's like giving someone directions to the grocery store, but they end up in another country because they took your instruction to take the fastest route a bit too literally.
That's a great analogy.
Yeah.
And this is where the whole issue of control becomes super important.
Right.
Who gets to make decisions when things go off script?
Yeah.
Especially with AI getting more and more autonomous.
Right. We can't predict every scenario. And even if we could, like, writing a rule for every possibility would be insane. So the paper talks about these residual control rights.
Right.
Who makes the call when AI encounters something unforeseen?
Exactly. And the authors suggest we kind of, play to each other's strengths here. Humans and AI have different abilities, and that should inform who's in charge when.
Okay, so what would that look like? Give me a real-world example.
Think about a self-driving car again.
Okay.
In an emergency, like someone suddenly swerving in front of it, the AI needs to react in milliseconds.
Right.
Humans just can't process information and make decisions that quickly.
Right.
So in those split-second scenarios, it makes sense for the AI to be in control.
But we still need to be the ones setting the overall goals and boundaries, right?
Absolutely.
Making sure the AI is aligned with our values and isn't going rogue on some crazy mission of its own.
Absolutely. The paper suggests that humans should retain control over those big-picture strategic decisions. What are the overall goals for this AI? What are the ethical lines it should never cross? How should it interact with the world in a way that aligns with our values? Those are calls we need to make.
So it's like a partnership where the AI handles the tactical stuff, the fast-paced execution, while humans are the strategic leaders, providing guidance and direction.
I like that. But there's a catch.
There's always a catch, isn't there? Tell me more.
Even if we hand over those, fast local decisions to AI, we need ways to detect when those decisions start adding up to a bigger risk. It's like giving someone the power to make small purchases without needing approval for each one. Individually, they might seem fine, but over time, those expenses could really add up.
Ah, so even if each individual decision the AI makes seems safe and logical on its own, the combined effect could still lead to unintended consequences. We need some kind of early warning system.
Precisely. That's where designing effective feedback loops and monitoring mechanisms becomes crucial.
Right.
We need a way to track what the AI is doing, assess the overall impact of its decisions, and alert humans when things start going off course.
And those alerts need to be in plain English, right? No point in having a warning system that only another AI can understand.
Absolutely. The information needs to be clear, concise, and actionable. Humans need to be able to understand what the AI is doing and step in when needed. This is why the idea of residual control rights is so important. We need to predefine who has the authority to intervene in different situations.
Okay, so we got to be strategic about dividing control, making sure AI is making the fast decisions it's good at, while humans maintain oversight and can step in when things go sideways. But how do we actually put that into practice?
That's where things get really tricky. We need to think carefully about what kinds of decisions are best suited for AI versus humans, recognizing their strengths and limitations.
For example.
Well, AI excels at tasks that involve speed, massive amounts of data, or complex calculations. Things like managing financial transactions, analyzing medical images, or controlling a power grid in real time. These are areas where AI can outperform humans by a long shot.
But when it comes to making judgment calls, weighing ethical considerations, or dealing with situations where there's no clear right or wrong answer, those are areas where humans still have the edge.
Exactly. So one approach could be to pre-agree that AIs handle those fast local decisions where they have an advantage, while humans retain control over the bigger strategic choices that require judgment and ethical reasoning. But even then, we need robust monitoring systems to make sure those smaller AI-driven decisions don't snowball into larger problems that violate those bigger goals.
So it's all about finding the right balance,
Yeah.
figuring out how to leverage the strengths of both AI and humans while mitigating the risks.
Right. It's a complex dance, and we're still learning the steps. But this idea of thinking about AI as a system rather than just a collection of individual models is a crucial step in the right direction.
Okay, so we've talked about the potential risks of subgoal emergence
Yeah.
and the need for clear residual control rights to manage those risks.
And we've highlighted just how important it is to design those control mechanisms carefully, considering the strengths and limitations of both humans and AI.
Right. But there's one more thought-provoking idea from the paper that I think our listeners will find fascinating. We've talked about AI learning through like interaction and stuff,
Right.
but this paper goes a step further and suggests that giving AI more senses, like an actual physical body, could be like a total game changer for its learning potential.
It is a pretty wild idea.
Yeah.
They're suggesting that giving AI like a robot body
Right.
could make it smarter.
Hmm.
Think about how much we learn through physical interaction with the world. We develop a sense of space, object permanence, cause and effect, all these fundamental concepts that shape how we understand reality.
Right, like a baby dropping a toy and realizing it doesn't just vanish, it falls to the floor because of gravity. That's not something you can just program into an AI.
Exactly.
It has to experience it.
Exactly. Those core understandings emerge from like the interplay of senses, actions, and the feedback we get from interacting with a physical environment.
Mm.
An AI with a body could experiment, test hypotheses, and develop a much, much deeper understanding of how things work than an AI that's just processing data.
So we're not just talking about AI that can think, but AI that can learn and develop in a way that's much more similar to how humans do. That raises a whole bunch of new questions, doesn't it?
Absolutely. If AI starts learning in this like embodied way, could it develop its own unique forms of understanding that we might not even recognize? Its experience of the world would be fundamentally different from ours because it's learning through the lens of its own, robot senses and capabilities.
Whoa, now we're really getting into uncharted territory. AI that's not just smarter, but potentially thinking in ways we don't even fully grasp. That's both exciting and a little scary.
Yeah, it definitely highlights the need to be thoughtful about the implications of this increasingly sophisticated AI. We need to be asking ourselves not just what AI can do, but how it will learn, how it will evolve, and how we can make sure that aligns with our values and goals.
This has been a mind-bending deep dive.
Yeah.
The systems view of AI really opens up a world of both incredible possibilities and challenges that we need to be prepared for.
It's a topic that deserves our attention, our curiosity, and our willingness to have, open and honest conversations about the kind of future we're building with AI.
Well said. We've only scratched the surface today, but it's clear that the systems view of AI is like crucial for understanding where this technology is headed. We hope this deep dive has given you some food for thought and maybe sparked some new questions of your own. What are your thoughts on the potential and the risks of giving AI a physical body? We'd love to hear your perspectives, share your thoughts on our social media channels, and until next time, keep exploring, keep questioning, and keep diving deep.